All right, today we're going to talk about 9 through 12 and then also do some things about ionic naming. So first of all, go ahead and go to page 2, question number 9, and let's talk about anions and cations. So here are some definitions. A cation is an ion with a positive charge, and the reason why it has a positive charge is because we have lost electrons. So one way to remember cations is that the T looks like a plus sign, or maybe you want to think about cats and how they have paws, so they have a positive charge, or maybe you just really like cats. And so a cation is one of the two categories of ions that we have in chemistry. So an example of this would be your sodium. We talked about these yesterday. So for example, sodium wants to lose an electron, this one specifically, in the outermost shell. And when we lose it, we're losing something negative. So when you lose something that's negative, things become more positive. So we have a +1 charge. Another example of a cation is aluminum with a 3 positive charge, or calcium with a 2 positive charge, silver with a 1 positive charge. Notice that all of these have a positive charge. Okay, the next category of ions are called anions. And anions is an ion with a negative charge. Oopsie, negative charge, that's the negative right there. And this happens when atoms gain electrons. So the way I like to think about this one is that if you're anti something, like anions, sounds like anti, then you're against it. It's something that you don't like. And so that's what I think of when I think of anion, is that it has a negative charge. So some examples of this would be nitrogen with a 3 negative charge, or chlorine with a -1 charge, or oxygen with a 2 negative charge. So notice that all of these have negative charges. And that's again because we're gaining electrons, and electrons have a negative charge. Okay. So which elements from above, if we look at number 10 on our paper, which elements above form cations? So look, does sodium form a cation? Does chlorine or magnesium or phosphorus? And we're just going back and looking at these questions right here that we talked about before. So for number 10, which elements form cations? Remember that sodium formed that +1 charge, and that magnesium had a +2 charge. So those are the two that formed cations. And then if we look at number 12, it's asking us which ones formed anions. So if you remember, the chlorine had a -1 charge, that's an anion, and the phosphorus had a 3 negative charge. So those two are the anions that are formed. Okay, let's go ahead and continue. Okay, so here's an example of an anion. Here's chlorine, and if you notice, it has 7 valence electrons around it. So again, remember, think about what's going to make this more stable: adding 1 more electron or getting rid of 7. So the easiest thing to do, the thing that takes the least amount of energy, is to gain 1. So when we gain an electron, this is what we get right here. We're gaining this electron, which means now that we have a negative charge. So again, this is an example of an anion. Okay, so take a minute, pause the video, and I want you to predict the ions that will be formed by the following atoms. You can look at what's going to gain stability and take the least amount of energy. You can also look on the back of your periodic table, on the back of your page, and look at the trend of what is happening in that column. Okay, go ahead and take a moment. Okay, let's come back. So hopefully this is what you got. Lithium has a +1, oxygen a -2, aluminum a +3, and calcium has a +2 charge. All right. Okay, next thing, polyatomic ions. So I want you to break down this word. So what's poly mean? Poly means many. Atomic means atoms. And ion means that we have a charge. So the definition of polyatomic ions is many atoms with a charge. So go ahead and put that down. Okay, and here's a textbook definition. Ions formed from more than one atom, and they have a charge. So here are some examples. CO3 with a 2 negative charge is carbonate. PO4 with a 3 negative charge is phosphate. And if you look on the very front of your packet, you have a whole list of common polyatomic ions. This list I want you to become familiar with as we do them in class, and you will be able to use this list on your test. And so no need to memorize, we just need to know how to use them. So what happens in a polyatomic ion is the charge is dispersed along the entire molecule. So for example, this this 2 negative charge means that we have 2 more valence electrons, and it's helping make this substance, this polyatomic ion, stable. Like when we do Lewis structures, remember we'd always add the negative. Same thing here with phosphate, you needed 3 more electrons to become more stable. Okay. All right, so this is just kind of a game we played today. So I put up a name, and you look at the list of polyatomic ions on the front of your packet, and you would just write down, oh, sulfate, and you'd find it, and it has an SO4 with a 2 negative charge. So I'll put these, and you can like stop the video and look for them. So another one is chlorite, silicate, cyanide, nitrate, and borate. Okay, the opposite of this is doing the formula and then saying the name. So go ahead and go find OH with a negative charge. OH with a negative charge is hydroxide. And then go ahead and like pause the video as we do the rest. So this one is CO3 with a negative 2. Then we have ASO3 with a 3 negative charge. O2 with a negative 2 charge. And PO4 with a negative 3 charge, and NO2 with a negative 1 charge. So go ahead and find their names. I can hurry and tell you, this one right here is carbonate. This one is called arsenate. Arsenite. Arsenate has a 4. Peroxide, nitrite, and phosphate. Okay, I just want you to, again, become familiar with these polyatomic ions. All right, so now I want you to find the polyatomic ion in each formula. So again, you might want to pause the video and look for things. So right here, this is your polyatomic ion. It's the OH with a negative charge. In the formula, it doesn't have a charge because it's bonding with the beryllium to make things neutral. This one right here is SO4. The 2 negative charge, that's sulfate. So again, I'm just wanting you to be able to recognize these. NH4. This is NH4 with a plus sign. That's called ammonium. This one is NO3. And on your polyatomic ion sheet, it has a negative 1 charge. This is called nitrate. And so notice all of them that we just talked about, they have 2 or more atoms. And when they're not bonded to another atom, they have a charge. Okay, let's talk about naming ionic compounds. So turn your page in your packet to page 3. This is just kind of some fun little things right here. And let's go ahead and let's do numbers 1 through 3 together from the slides. So first of all, a binary ionic compound. I want you to think about the prefixes here. Bi means 2. So a binary ionic compound is a compound made of 2 ions. An ionic is made from a metal, which is a cation. Remember, that's the positive charge. And a nonmetal, which has a negative charge. And this is what makes up an ionic compound, is a metal with a nonmetal, and the metals are always written first. All right, so here's an example right here of a binary ionic compound. We've got our metal, and when we're trying to make it stable, it has a +1 charge. And here's our nonmetal, and when we're trying to make that stable, it has a -1 charge. So the sodium says, I don't want that electron, and the chlorine says, I want that electron. And so they transfer the electrons, and they make a very stable ionic compound. Okay, the second part that I want you to look at here is called a monatomic ion. So the prefix mono means 1. Okay. So right here, it's an ion. Again, an ion is an atom with a charge that is formed from one or a single atom. So for example, right here, that's sodium ion. This right here is a chloride ion. They're by themselves, and so they're a monatomic ion. Here's some more examples right here. There's chloride ion, nitride ion, sodium ion, and vanadium ion. And again, these are their charges according to their stability on the periodic table. So the chloride and the nitride want to gain electrons to be more stable, and the sodium and the vanadium want to lose electrons, so they become a positively charged ion. Okay, what I want you to do is pause the video, go to this page 3, and I want you to just look at the patterns in A through F. See if you're seeing anything that's similar. See if you can notice any kind of trends. And then what I want you to do is go to page 4, and I want you to just to write down the patterns that you're spotting. And then I want you to play the video again after you're done with that. Okay, welcome back. So now that you're done, hopefully you noticed a couple things of the patterns, and if you didn't, it's okay. But if you notice on this pattern that every single product that we're making right here is made from a metal and a non-metal. So the metal comes first and the non-metal comes second. Another thing is that all of these are neutral, which means they don't have an overall charge on them at all. And also what you're seeing, hopefully, is that on the reactant side we have these charges, and the charges always neutralize themselves out on the product side. So for example, on D, aluminum has a +3 because it wants to lose 3 electrons. The oxygen has a -2 because it wants to gain 2 electrons. So we're trying to find a common multiple of 3 and 2. That common multiple is 6. So in order to make aluminum have a +6, we have to have 2 of them, which is why we have 2 right here. And in order for the oxygen to have a 6, we have to have 3 of them, which makes 3 times a -2, a -6. So up here we get a +6 and a -6. And we'll talk more about this, but you're making things neutral. Another thing hopefully that you noticed is that the naming of these, like for example sodium sulfide, the first element, which is the metal, keeps its name. It's like a normal name. And the second one, the ending changes to "ide," and that's kind of interesting. Ide, chloride, oxide, sulfide. And then the ones that have polyatomic ions, their name doesn't change. Okay. Let's now go back to page 4, and I want you to go ahead and fill in the rules for writing ionic formulas. Okay, sorry, I jumped ahead a little bit. This is just saying what we just talked about. Sodium has a +1 charge as an ion. The chlorine has a -1. And so together, those charges cancel and they just create sodium chloride. So if you notice here, we're just predicting how many we have. Like right here, we have this +1, and then we have like a -1. So we only need 1 of each. You'll see that with these next slides. Okay, we have to have 2 sodiums to 1 sulfur, so we have a plus. We have a -2. Notice that my charges are canceling out here. Okay, this is just kind of a fun visual for you. Again, on this one, +2, so we have to have 2 chlorides. So we have 2 chlorides. Sorry, that should be negative. It's going to make a -2, which cancels out the +2. This one does the same thing. We've got aluminum here, and then the oxygen. You can pause the video and look at that. Same thing here. Okay. So I'm going to hurry and just skip these really fast because we're going to come back to these tomorrow. But I want you to write down the 3 rules, and you can go ahead and pause these. So there's 1, name the monatomic ion cation present. Number 2, name the monatomic anion present. Notice that the ending changes to "ide." And the last rule is polyatomic ions always keep their own name, so you never change their name. Okay, tomorrow we're going to put these together, and I hope this helps. Have a great day.